Hi, this is Rashad, and I will be doing the Pencast for Homework 2, Problem 74. So the problem says, a physics professor demonstrates the Doppler effect by tying a 600 hertz sound generator to a 1 meter long rope and whirling it around her head in a horizontal circle at 100 rotations per minute. What are the highest and lowest frequencies by a student in the classroom? So I drew out this picture beforehand, but this is what it looks like. It's a professor who has a 1 meter long rope and which has like a speaker box, which is like outputting a 600 hertz frequency sound and rotating the rope around her head in a horizontal circle at like 100 meters per 100 rotations per minute. And there is a student in the classroom who is like observing these frequencies, and it's a Doppler effect problem. So when the speaker is like in a rotation and it's rotating this way, it's rotating towards the student. So and then when it's rotating this way, it's rotating away from the student. So you're going to be getting like different frequencies or wavelengths when the rope is whirling around the professor's head. And the problem is asking you to find the highest and lowest frequencies that are heard by the student. So beforehand, I wrote down the Doppler effect equations. This is going to be, F plus is going to be when the speaker box is moving towards the stationary student. We will be using this equation, and then this equation when the speaker box is moving away from it. So now let's start off by writing down all the variables that we have. So the first one we have is like the speaker box is outputting a 600 hertz sound. So let's write that down. And we know that the radius of the rope is going to be 1 meter. We know that the revolutions per minute is going to be 100 rev per minute. And we are looking for F plus, so we don't know that. And we are looking for F minus, so we don't know that. And we know that the speed of sound is 343 meters per second. So let's write that down. And so we have almost everything in our equation except for the velocity of the source sound. So we need to calculate Vs. Okay, so let's start out by counting Vs. So we know that Vs, velocity of the source sound, is equal to radius times rotations per minute. And we have both of those. So let's just plug these numbers in. The radius is, again, 1 meter. And the rotations per minute is 100 revs per minute. And then we will also be multiplying it by 2 pi radian, because it's in a circle, over 1 revolution, and multiplying that by canceling out the minute, because it's going to be in meters per second, so we want it to cancel out. So the revolutions cancel out, the minutes cancel out, and so now you're just left, and I did the math beforehand, but you can check this, but it's 10.5 meters per second. So now we have our velocity of the source sound. It's going to be equal to, excuse me, 10.5 meters per second. So now all we do is plug all of our variables into the two equations over here. So for F plus, it's going to be 600 hertz divided by 1 minus 10.5 meters per second divided by 343 meters per second. And our second equation is going to be, sorry, I'm running out of space here, but again, 600 hertz divided by 1 plus, because it's moving away from the source sound, 10.5 meters per second divided by the speed of sound. And these two equations I calculated beforehand, but the answers are 620 hertz and 580 hertz. So the highest frequency heard by the student is going to be 620 hertz, and the lowest is going to be 580 hertz.